I'm going to get us started here today, talk a little bit about our company, our value proposition with our Aramid fiber products. We have Ace XP as well as a couple others we'll introduce you to. And we're going to look at a couple of different areas, including our performance and performance data. We have a couple case studies to share, and then talking a little bit about our product composition, how it's easy to work with, doesn't really fly away, which is a big fiber challenge at times. And then we also want to dig into the wet versus dry polymer. There's a lot of familiarity with wet polymers, and our product has a very interesting comparison. We also are looking into the sustainability and EPD challenges that the industry is looking at. We play a great role and have already done a lot of legwork there. And then, it's most important when you're talking about implementing technology to think about, how are you going to do it? And we have a machine that we'd like to introduce you to called the Defender, and some of our dosing process and reporting, really tying it all together into actual function. And then we'll break for question and answer after a quick video on the machine. So there we go. We believe in better. What does that mean? Well, ARCA, which is aramid reinforced composite asphalt, is the premier and engineered solution. And what we mean by that is that it's a product that can come in and help asphalt, whether you're being challenged by aggregate issues, polymod, supply chain, inflation. We're able to bring aramid in to a number of those challenges and make a big difference. And why are we better? There's a lot going on right now. BMD, EPD, raw material challenges. The Ace XP polymer fiber can go into any mix, increase performance, and help. We also have a product called ReArm that's a high wrap product that allows for a interaction with a rejuvenator type product to get a superior performing high wrap material. We also have a product called Army, which is 1-inch reflective crack interlayer. It's very flexible. It allows you to cover up distressed pavement, concrete, anything that is a challenge with a potential remove and replace. As long as the base is in good shape, you can put Army over top of it and cover it with another surface mix and get a really long-lasting overlay solution. Let's see here. There we go. No? Hi. Sorry, everybody. Had a little... There we go. My mouse finger got a little strange. When we talk about our value proposition, we focus in on 4 core areas. Cost effectiveness. How are we comparing to polymer modification, not just in performance, but also in cost, ease of use, efficiencies? How do we compare in commercial mixes? Where do we deliver value? We also look at the performance to deal with balanced mix design, cracking and rutting, but there's also a structural element as well that is fairly unique as a performance additive. We're also doing a lot of work with that plant adoption. The Defender is purpose-built, and the reporting function on it is great. It allows for people to have high confidence in what's going on with the fiber. And then sustainability. It's the buzzword. You can't do anything without addressing the sustainability angle, and we're really proud of how we fit in there. And with that, I'm going to kick it over to Taylor Schmidt to introduce himself and walk you through the products a little bit.
Awesome. Thank you so much, Mike. Before I get started, I just want to give you guys a brief little snippet of my history here in the paving community. I think it's important, and it'll kind of show where I started and where I'm at and why I'm so passionate about surface tech and the products that we offer. I've been in the industry for about 12 years, started out at Titan Transportation, a little transportation company. We handled all the hauling of everything for Vulcan materials. Worked on a paving crew named for a company called Marathon General for about a year, top 5 pavers in Southern California. moved into a sales manager role for California Commercial Asphalt and Escondido Materials for about 4 years, and then got swooped up by the refining side over at Lundy Faggard, which became World Oil. So I've touched literally every single portion of this business, with the exception of maybe working inside of a quarry or something like that. So I've shoveled it, I've hauled it, I've sold it, I've sold the liquid side. So I understand the impacts of the poly mods and the leveling courses and the interlayers and all those things. So thanks again, Mike. So my first slide here. So we're more than a chemical modifier. Our flagship product, ACE XP, physically reinforces the pavement. We make asphalt stronger, lasts longer, and it's the only performance mix modifier with a published EPD. And we are also the only performance modifier on Napa's Eco Green tool. So that's kind of the basis for what we're going to talk about here over the next 5 slides here. So if you can move to the next one for me, Mike. So as Mike mentioned, we have Army and Aramid reinforced mix interlayer, highly impermeable. It reduces cracking, and we do that with the data that we have in place. We have data to support that we're 30 to 50% longer in the lifespan of the asphalt.
Army also is something, Taylor, that we have some flexibility with because of the local materials.
Exactly. Yeah, and that's the beautiful thing is you as the supplier. So I think we might have some granites and some Cal Portlands and hopefully some Mart Marietas and Vulcans out there. You as the supplier get to use your own current ag supply, your own oil supply. We're not, we're going to provide the everything else beyond that to be able to make that and provide that interlayer. And like I said, we have the data to back up that we have that we create that unparalleled crack resistance. So it's a nice little thing for the supplier themselves to be able to not have to change anything. We're just adding one more product to that. If you can go to the next one for me, Mikey.
I was just going to give Phil a quick opportunity.
Oh yeah, Phil, jump in there. Phil's great, a great
Phil's
resource.
our technical consultant for some of these types of engineered products.
You there, Philip?
Yeah, there we go.
Okay.
So yeah, glad to chime in on this one, and good afternoon from Kentucky, everyone, and hope everyone's doing well. I've had a chance to work with the product, and I keep my samples. I keep my samples close by, and this is the raw product they'll be talking about in a moment. This is the bound product that keeps it from having a material loss at the plant. I've been using it since 2016, evaluating it, I guess I would say, and now as a consulting engineer, I actually bid it on projects. I've actually used it. I was having some fun earlier, playing with it and doing some fun things with it. That's the interlayer product with it. But in the essence of what this is, it's a polymer that's made into a fiber that's put into a mixture. You don't have to worry about compatibility. You just put it in, it works. It doesn't change the mix design. It adds cracking resistance. It adds rutting resistance. It adds structure. It adds structure to the pavement by about 20%. You have folks who have switched over to it. Those who use it, everybody and I get called if there's problems. If everybody that I've heard of fall in love with it very quickly, maybe that's a little bit strong of a word, but they really enjoy the product, because one thing that we're missing in asphalt mixtures, and I've sort of worked in both worlds, but in the concrete world, rebar was invented to allow us to build vertically, and then to be able to do more things horizontally, where we keep the cracks from coming in. Asphalt's never been thought of as a structural material just because it's pliable. aramid reinforcement adds a structural component to it that we've been missing without causing it to be a rigid pavement. So it's still a flexible pavement, but it adds a structural component, giving a 3D reinforcement. I think in the upcoming years, it's going to be as common in asphalt as what rebar is in concrete. But now we tend to think of things just asphalt and rock. So if you want to think of it in a simplistic form, think of it as a dry polymer that's put in. I'm here to help answer any detailed technical questions. I've done site surveys. I've done FWD evaluations with it. I've got knowledge from everything from the bidding to the construction side, and glad to answer any questions. Taylor and Mike, you know, guys, I'm sold. I also I like it so much. I consult with the company, right? So, yeah. But with that, as any questions come up, please ask away, and I'm glad to kick in with that. It's not only used in a regular mix; it's used in, as they're mentioning here, in the rearm product, where it is where it's been used up to with 45% wrap. You could use more. It's just what the contractor is capable of doing. And again, it adds a high performance aspect. We can use in the interlayer, any aspect of paving you can think about. This is where this could be used.
Yeah, absolutely. And to tag on to that, Phil, and thanks so much for that. You know, wrap is very different market to market in terms of availability, but our goal is to give you the option, depending on where you're at. If you're in Southern California, you more than likely have a mountain of wrap, and the chances that you're going to get to chew through that in a reasonable amount of time. I've seen stockpiles, you know, as tall as 5-6 story buildings. So we want to give you guys the option to double that amount of wrap. And you just have to deem whatever project would necessitate that type of move. There's going to be some things like Caltrans and certain specs, so you're not going to be able to do that. But with this product, you have that option, a reliable option, and we have all the data to support that. And like I said, you can hit us up in the comment. I don't know if we have a comment section, but we can get emails out there afterwards and just let us know if you want any of that information. We can get that over to you. And Phil kind of touched on most everything that I wanted to talk about with that one. So I appreciate that, Phil. You're making my life easier. Moving on to performance. It's, as we said, significantly improved cracking and rutting resistance, improved structure modulus. As industry dives into mix design optimization and mix structure, we feel that this is a valuable asset in this effort. With that said, the ease of adoption, it's safe, easy, and clean for planning implementation, and I'll touch on that on a later slide. You have the optional PE cert, and then I'll share more about the Defender kind of here at the end of the presentation, with all the daily reports and all the information that machine provides. It is a purpose-built machine, as Mike said before. It's not some off-the-shelf thing that we just kind of repurposed. It has a true meaning for our company and for the industry. Sustainability, we already touched on. We see an average of with testing a 30 to 50% increase in life expectancy of the asphalt, reduced carbon footprint, and that EPD certification. So I'll get more into that reduced carbon footprint with my history in the refining side, and not only producing polymod asphalts with my time at World Oil, and also with my time at California Commercial Asphalt and Escanaba Materials, having to purchase terminal blend rubbers and things like that. We'll go over that, and most importantly, the cost savings, which I think is what most people are concerned with in today's day and age. It's not getting any cheaper to do these tire rubber modified terminal blend mixes. You see anywhere from a $200 to, you know, in Southern California, $250 difference between neat asphalts and modified asphalts from the refinery. So, and obviously longer life. Longer life means those budgets that come out every year. You're not replacing a road, you know, nearly as much as you're going to get more time out of that. So if we can go on to 10 there. And if anyone hasn't seen our product, this is just a nice little illustration of our flagship product, the Ace XP. And what it is, it's those aramid fibers which are used in Kevlar. So they're used in bulletproof vests and everything kind of in between in that market. Dipped in sesavit wax. A lot of times folks will call them toothpicks or matchsticks or something along those lines. It's just kind of whatever lingo or slang you guys want to give to it. We have two different sizes, 19 millimeter and 38 millimeter. And in each of those little bundles, you're looking at 10 to 12,000 fibers per matchstick, which equates into 10 to 12 million fibers per ton of asphalt. A lot of people don't understand why it's dipped in wax. It gives us the option and the opportunity to introduce the fiber on the wrap belt. Oftentimes plants can be a little bit tight on real estate. That gives us the opportunity to move our unit kind of further away from the heart of the operation. It's something that your field guy can come and check in on, make sure the hopper's full, make any adjustments that he needs to make. And also you get to see that fiber going up on the belt. There's no guesswork, no question mark as to whether it's actually making it in there. You're going to see it traveling up the belt. The wax essentially adds weight to the product, keeps it on the belt. It's not going to blow off. It's not going to fly away in the wind. That wax melts at 170 degrees. And you know just as well as I do that those asphalt plants operate well above 170 degrees. So that wax disappears, gets blended into the asphalt. And the big thing and the big selling point is there is no change to mix design or laydown. You don't have to, there's no extra process. Your QC guy or your lab tech isn't going to have to look at this product and say, okay, well, here's the mix design we're using. I got to bump oil content from here to here. Everything gets to stay the same. And like it says on the next bullet point, no extra liquid binder. And you can see the tensile strength listed there. And I think, Phil, correct me if I'm wrong, it's we end up being that number is 5 times stronger than steel. And it's a huge benefit. So just much like Phil mentioned, the rebar and its purpose, we're right in there. So, and the 800 degree melt temperature, I don't know when it would ever reach that. So you have the peace of mind knowing that, you know, I think we've all heard horror stories of refineries and asphalt plants heating something up well to its flash point and having issues. We're nowhere near any critical temperature. You know, nothing has to change. So that's pretty straight ahead. I'm going to turn it back over to Mike. And if anyone, Phil or Ron, if you guys want to add anything to what we just said before we move on, or if not, Mike's going to take charge here.
Hey, Mike.
Yeah.
Tony Lemus. Hey, I got a question. Have you experienced a DOT that is requiring the fibers to be weighed individually, where they don't allow you to throw them on a wrap belt and they say, hey, you need to have a device that will weigh them as they're going in?
That's exactly what the Defender does. Is the Defender has load cells, and every 10 seconds we take a precise measurement within a tenth of an ounce to assure that what the spec calls for is exactly what you're getting.
Okay, so the Defender is upstream of the wrap belt.
Yes.
If you're going to put them on a wrap belt, the Defender measures them, goes in or lock, gets recorded, and then they just drop on the wrap belt.
Absolutely. We have a video.
Wrap belt weighing device, so it doesn't interrupt that, doesn't cause any confusion there.
Exactly. Yeah, and we have a video that Mike will show after he wraps up these next couple of slides, and we'll be a little bit of it. Yeah, but we have a very clear pathway and visual for that. Absolutely.
Cool. Thank you.
Sure thing, Tony. Good question. That precision dosing is really important. A lot of reasons that we can dig into a little bit later, but great question. So Dixie Highway is a case study we would want to bring your attention to because it has a really awesome 6-year crack count data set. And we just showed you the graph here. It's linear feet. You've got hot mix asphalt with fiber, hot mix asphalt without. It's 4.5 inches over concrete that had reached the end of its service life. And the crack counts are really, really interesting. You can see that they have basically the same shape, meaning that over time, the asphalt does crack, but the difference in those cracking results are huge. We expect this to continue. The difference in the cracking on the fiber side is significant, not just in linear feet, but also the deterioration of those cracks. They're not necessarily connecting as quickly. They oftentimes are much tighter. And I'll show you a picture here. Hopefully you can see that okay. But there's a crack going right through the control lane that stops at the fiber lane. And that is something we're very proud of. It's something that we do see pretty often. And maybe someday later that crack will continue. But by that time, the control side will be in a much, much higher need for maintenance. And then something for California. You know, we've talked a lot about substituting fiber for rubber, but we also know there's a lot of energy going into recycled products, including tires, and that you guys are going to be, based on the current legislation, there's going to be rubberized asphalt in California. Well, it turns out the state of Florida was also kind of looking at trying to increase the use of recycled materials and get away from polymer modified, but it was their standard high polymer binder was the standard freeway binder. And so they needed to figure out how to do that because they had seen some differences with the rubber to the polymer as far as performance, and they didn't want to give up any performance. So they hired Texas Transportation Institute to dig into it. They did a whole bunch of testing. We would be happy to share the full report to anybody that wants it. But this graph shows on a crack index basis how we grade it out. That if you take a rubberized binder and you put fiber on top of it, you get a higher performing product than polymer. And so it's food for thought for you guys, especially headed into balance mix design. And, I did want to kick this over to Ron if he had any comments about using fiber in conjunction with upcoming BMD there in California, Ron or Phil. But it's a really exciting data point for us. We're very proud of the fact that we play well with others. Other asphalt technologies benefit from fiber, just as basic asphalt technology benefits from fiber. So, gentlemen, I don't know if you have any comments.
Well, and Mike, I just came back from visiting the test track too, and I think maybe just to add to that, everybody's gone wild over ideal CT, and it's an indicator test, and I know we all know rubber has benefits that this test won't pick up. Likewise, this test won't pick up certain benefits of what fiber will do, where beam fatigue and other things will. But bottom line, what this does is not only show you cracking, but it just sort of weeds out in ranks if you think of it like that. So not only do you get a good ranking on this, but the difference you're not seeing, and this is not putting rubber down, it's just telling you a benefit. Rubber does not give you structural reinforcement. Okay. Matter of fact, you actually get, it's more meant to be more pliable. With aramid fiber, you get the cracking resistance without sacrificing the structure. And that's one reason this sort of lights up a bit in this test as you see that crack initiation and then what they call the propagation, or the how it wants to hold together afterwards. And that's why you see that pop up like it's doing there. It's the fiber going to work.
Thanks, Phil. Okay. All right, so we'll go back to Taylor here to talk a little binder talk.
Yeah. So the fiber modified advantage is pretty clear. there's, like I said before, there's no compatibility issues added at the mix plant. And to kind of elaborate on something I spoke on, I might have breezed over it a little too quickly. We do boast our, it is a reduced carbon footprint. So less environmental impact than producing a liquid ton of TMAC or polymod at the refinery. And a lot of times, and hopefully this is an advantage that speaks to a lot of to a lot of the producers, is not all of us, some of us, but in my experience, we never had a tank that we could specifically allot just for polymods or tire rubber modified asphalts. It does create a bit of a headache on the back end for that operation. So you're not tying up a tank. We only require 110 volts on our machine versus the amount of energy that it costs to produce a ton of asphalt on the refining side. You're not superheating asphalt to get rubber into it, or all the mills and things that go in place with the polymod side. So that's, I feel, a great advantage. You don't need that extra tank. So how the fiber works is it acts by rooting into the mixture, creating a 3D matrix. So just think of a really intricate spider web made up of 10 to 12 million fibers, and what that means for your mix, as far as the lifespan, the increased lifespan, the workability, and there's no change to the mix design, as we touched on before. Your lab guy's not having to do any extra effort. No change in mix temp, and we have availability in all markets. Typically, if you place an order, that it's something that we can fulfill. Everything within reason, obviously, but it's something we can fulfill very, very quickly. In the Southern California market, it's something that I do personally. And then beyond that, since it's a little bit out of my reach, we have the stock and the ability to fill those orders really quickly. So available all the time and can be easily added to any plant using our equipment, or for smaller jobs and smaller plants, we have other options for that as well. And the cracking and running resistance. So the advantage is there. And we hope that you see that with us as well.
Also, Taylor, just to add a touch on the BMD side, the fiber advantage over liquid polymer extends to dosage, because your binder grades are pretty much set, right? Like you get certain performance from different binder grades. But what does that mean when you're trying to fine tune your performance envelopes? And the variable dosage of aramid fiber, you can add some, you can add a lot, you continue to get benefit linearly. So if you're getting 30% with one dose, you'll get close to 60% with two, and etc. And you can take that and really use it as a plant-based tool to fine-tune performance, no matter what the base binder is.
Mike and Taylor, I've even heard, like, Kentucky's already moved to balanced mix design, and we've heard of contractors here and others. And I know it's normally not in the lingo of surface tech, but I've heard contractors talk about a half a dose, a dose and a half, whatever it takes to meet BMD. And again, the nice thing is by accident, this is sort of funny, but by accident, a University of Alberta put in 10 times the amount. They just got the decimal off in the lab, and they put in 10 times the amount. Now the results were off the chart, but what was funny, it didn't change any of the volumetrics, so it just worked. Now, naturally, the sales guys up there were very quick to say, we would love to sell you that, but we don't think it's realistic. But it's funny, it did go in, and it was mixable, and we had never done that before, but never needed to, but that's how easy it works. And it's very scalable.
That's a great point. Yeah. Thank you, Phil.
All right. I'd like to take a minute and dig a little bit more into the sustainability angle. You know, here in Colorado, I sit on an EPD task force. We've been mandated by the state through legislation to establish carbon benchmarks for the materials that are purchased by the state. That's both the Office of Architecture as well as the DOT. So it's all state money. And that's in effect. Right now, if you're awarded a project over $3 million in Colorado, you will provide an EPD. It's not currently used to decide who gets the award, although I find it challenging to believe that's not the immediate following step, but it is part of the process that we're in. And, you know, we're looking at this cradle to grave type math. And the fact that ACE XP adds life, adds years to average standard 2-inch overlays, which I think we all have a very good feel for how much of our industry is defined by a 2 to 3-inch overlay, is massive. It's massive. If you can add 3 to 5 years to an overlay, you have changed the math in a very, very significant way. And it really speaks to asphalt as a sustainable product. Yes, we're going to have to look at warm mix, and yes, we're going to need more recycled materials, but it's the lifespan that oftentimes defines that math. So we're exceptionally proud of the role we play there. I think there's a lot of effort from other additives and other industry sources on the life cycle issue, people trying to add years. And again, I don't know if there's an easier button than to just put fiber in it and it'll last longer. So we appreciate that role. And, you know, as we mentioned, we do have a published EPD. So there is a full documentation on our product, but that we've incorporated it into the Eco Green tool also kind of makes it an easy button, where you can get EPDs generated and submitted when required that will cover the ACE fiber product in addition to the rest of the mix. Okay. Taylor, if you'd like to take us out, talk a little bit more about the Defender and
the machine.
Yeah.
This beautiful piece of equipment here is our 3rd generation. It's known as the Defender. You have the option to do all variable dosing. So if you want more fiber, if you want less, we've created a piece of equipment that can be easily operated and handled by, you know, a few folks that you may determine that you want to run that machine on site. It's as simple as 2 to 3 buttons every time you interact with it, and it gives you the opportunity to, like I said, do more fiber, adjust the flow rate. If you're doing 350 tons per hour, just input it on the system. You're 2 buttons away from changing the flow rate on that machine. And Mike has a video that's going to show this really well. But to go back to what Tony's question was earlier, it's a way hopper, pneumatically charged, essentially, to drop the fiber into the bowl. The bowl is on load cells or weigh cells. And as we said, it's every 10 seconds, it's taking that measurement. So you have a very accurate and reliable source of information that's being stored in that tablet. There's a thumb drive on the piece of equipment that can be pulled off on the daily, or whenever you feel like pulling it off, taking a look at how much you've done, make sure that how much material you produced matches how many boxes and ounces of ACE XP that you've put through your plant. And it's just a nice feature that nobody else is doing right now. So I don't know if you want to show that right now, Mike.
I want to make one more point, if you don't mind, Taylor.
Please do.
The video is going to reflect what Taylor just talked about, the easy to use interface. We have gone one step further where we are at full plant integration. This machine can be integrated into plant control software. It is something that then can be fully managed by the control area, you know, your main plant controls. And at that point, you've got a ground person that just needs to come around and make sure she's full or has product present, depending on plant speed and other variables of that nature, like dosage. You kind of figure that out, but that's the only thing that your ground people have to do. And it's all the information can be displayed in the control tower, including the daily reports. That those
Right.
reports are things that can be managed through the normal plant process with control folks. And now I am going to, hey, come on. There we go. Show you guys this video real quick. All right.
We have volume there, Mike.
Luis
There we go.
Miranda. I've been with Martin Marietta for just over 5 years. I'm
What was that? I'm sorry.
No, I there was no volume for a second. I apologize.
Okay.
the filler here, aka ground guy. I run the fiber machines as well. So we've been running the Defender probably about a month and a half now. We were running the night jobs too. It's a lot of mix. I mean, we're making 3,000-4,000 a day sometimes with that stuff. So yeah, it's a lot of tonnage already been put through that. Day to day, it's pretty easy to run the fiber machine. You got time to run around, do stuff. The bowl speed's perfect. It's a lot more user friendly than the other ones. Yeah, the Defender is definitely the top notch one right now. It's going really well.
Okay.
Beautiful.
I'm going
Yeah.
to stop sharing. How do I unshare? Wait, there
Yeah,
it is.
so as you that's a really great illustration of how that machine works, and it's that simple. There's no you seeing the hopper, the material dropping into the bowl, the little paddle that we refer to as the tickler, knocking down any excess material, and that steady, consistent flow that's dropping into the hopper for the line back that can shoot that product. I've been in some situations as far as it in certain plant setups where we can move that product up to 150 feet of line of hose. The closer the better typically, but if your situation is special and different, we know that we can reliably and consistently move that product up to 150 feet of that hose and deliver that product just as it's intended. So I don't know if we want to, Mike, you want to start going through these questions? We have some questions that are starting to roll through here.
Yeah, I saw Steve also addressed them in the chat, but I'm going to read them to everybody just to bring it to everybody's attention. The first question was about the EPD. Is it for the product alone, or does it modify the HMA EPD? And it does both. However, utilizing that Napa tool, if you're using that to generate the HMA EPD, we're in there. So it's very easy to accommodate our EPD into the bigger EPD, bigger being for the mix. And then there was a question about production rate, about minimum production rate for the machine. Not really. I think what's important is that you understand it's kind of a variable. So whatever your plant is running, we can match it. In theory, if you were somehow running at 100 tons or less, it might get a little tricky, but normal production rates for modern asphalt plants, whether they're batch or whether they're drum, are addressed utilizing the machine, no problem. And that refers to Pat's question about, Pat Imhoff asked about batch plants. We are not just able to accommodate them, but we're able to accommodate them all the way to plant integration, where they're wired in through the PLC system, as we mentioned. It is something that I think as volumes grow will be more common. In the past, we were utilizing portable trailer equipment that would service jobs as opposed to individual plants. It would move around and take care of jobs. But now there's enough jobs that a lot of plants are just installing the equipment. T. Holly, we had this occur yesterday, 150 tons found unbound fibers.
I mean, would encourage you to reach out to us. That's something that we can address on the backside. We can look at introduction points. I'm not particularly familiar with what location this may be,
Yeah.
but please reach out to me or drop your email here, and I can reach out and we can troubleshoot that. No problem.
Yeah, and I'm, yeah,
Thank you.
there it is at ODOT, tholly@odot.org. Okay.
Got it.
Oh,
Great.
yeah. And, I did a calculation on that just for the fun of it, guys. When you look at a ton of asphalt, it has about 900 of those little sticks in it. When you go to a full truckload, let's say 25 tons, you've got 22,000 of those little sticks in it. So, if you see a spot or two of those, that's like finding an uncoated aggregate in your mix. It represents 0.0001% of what's going on. It's not desirable visually, but when you see something like that, that's not a problem.
It's also found the seasonality, this time of year, you could be working with wet aggregate.
Yeah.
There's a lot of factors that are going into that production that we would want to look at, but we can solve the problem.
Absolutely.
So, yeah,
Absolutely.
we'll reach out. Yep. We will reach out. So we appreciate that feedback.
I think it's important to share, however, for the entire group, that instance is a good one to talk about, because at 150, your plant speed's at 150, and you're finding that you have unbloomed, I think is the word here that was used. Sometimes the revolutions in the plant, in the drum, are not such that it brings a lot of concentrated heat and or agitation where it would break down that wax, even though the wax, being the carrier, is very thin. And it still needs to get up to 170. So if in certain spots of that particular mix that's not being achieved on a consistent basis, that might be partially what is causing that problem. So just want to make sure that you think about it from a mechanical standpoint, what's going on at the plant. Because it just is logic. If you think about it, you've got a third of the stick, each individual bundle has a third of that weight is wax. So it's only 1.3 ounces per ton of wax that's going in. I mean, that's you have to kind of get your hands around, your head around. If it is not melting in the drum, that's why you're seeing, unbloomed or covered fiber in that regard. And so you got to step back and try to figure out why is that. But there are means in which, if you reached out to Taylor, there are means in which we can correct that very easily. Just want to make sure that you think about this logically, because logic rules the day. This is not real complicated.
Absolutely. Thank you, Steve. Yeah. So, and as the main resource here in California, please, anyone on this call, reach out to me anytime. We do have options and ways to address certain issues. That's what we do. We're a partner for you guys to be successful, and we are always available, and we want to make sure that you have a great experience. And we have, like I said, we have ways to maybe different entry point and different opportunities there. So I'll reach out. That's great. Thank you.
Great. Okay.
Do we have any other questions that anyone wants to ask? You can message it, or you can unmute and ask it straight away. If Phil or Ron or anyone has anything they want to add.
Mike or Taylor, why don't you talk about the dosing, and then I'd like Phil to talk about a last point.
Right. Mike, you want to take it, or
Sure.
What do you feel like? Yeah.
Sure. I think what Steve's alluding to is the precision dosing. We talked about the variability. and we talked about how this machine works. And what that means is that you get a continuous dose of product, that the dosing itself is something that is worked into the system, as you could see from that video, where the material is incorporated in a stream. So it's not going in as one big lump per ton. And that leads to good dispersion. It leads to good practice from a manufacturing standpoint. It's a really good way to do it. And then we're able to track it so that your dosing record is very reflective of what actually is happening. There's no mystery to the dosing, and we're able to comfortably, for both producer, owner, engineers, all related parties, all stakeholders, are able to both on an instantaneous basis from the readouts that they're seeing, what averages are being displayed, things of that nature, as well as then a detailed report. The precision dosing is one of the things I think that with the bound product, since the weight is a known, how much fiber, how much wax, how much is supposed to be going in, how fast, you can get very confident in your statistics. I think that covers, is that what you're looking for, Steve?
Here. Yes, I think also it's probably really good to just really quickly make a statement on the dosage amount per ton. And I think that's really important for this group to understand. So, you know, you saw in an earlier slide that the dosage that Surface Tech is espousing is 3.4 ounces per ton. And that's made up of 1.3 ounces of wax and 2.1 ounces of aramid. And aramid is the active ingredient. And the wax is only acting as a delivery mechanism so that it is controlling that flyaway fiber into the mix, whether it's on a wrap belt or in through the wrap collar. So we don't want any flyaway, because that's a problem, because the minute you have flyaway with regard to aramid, because it's so lightweight, you start just, where is that going? It's not going in my mix, right? So the wax does nothing but control and deliver. So the active ingredient, which is aramid, is at 2.1 ounces per ton of asphalt, and that delivers that 15 million fibers per ton, and does proper dispersion when you're doing it in a continuous feed. That is very important to understand. 2.1 ounces is not a Surface Tech made up number. That is the universal accepted engineer DOT number that is been used for 2 decades in the industry. Other people tend to mask that 2.1 ounces with other types of bound product to make it a higher weight. And then there's this, unfair comparison, if you will, with regard to what is the aramid going into the mix, because that's what we're all about. It's aramid, not anything else. We're not about wax. We're not about plastic. We're not about anything but just aramid into the mix. Aramid is the key ingredient here, nothing else. So that's important for everybody to understand on the phone, on the call, because it is a very debated type of a dosage, if you will, and we've got to get down to that 2.1 ounces. And with that, I want Phil to kind of talk a little bit about what's going on at a nationwide level that could help bring clarity to all of this. Phil?
Thanks, Steve. Yeah, I'm heading next week to ASTM, where this has been in the works now going on about 2.5 years. And the goal of ASTM is just to standardize. It's no different than standardizing the binder that goes in the mix, the aggregates that go into it, a test device, a test method. What we're doing there is there's a test method, or there's a specification going forward that that where we've worked with, I personally worked with Forda, and I've worked with Surface Tech to develop a standard specification that says this is what's important. So if you specify aramid fiber, you don't get cellulose waste fiber, you don't get carbon fiber, you don't get steel fiber. This specification is one that has been agreed upon, that this is what defines aramid fiber. Because you call for it, you know, it's like you call for SBS polymer. Well, how do you know if you have good or bad SBS polymer? We don't, right? Nobody really ever thinks about that till this year when we're having issues, Steve. But, you know, I go and buy this product here. How in the world do I test that if it's good or bad? Well, you test it in the final product, which is the binder, and then the binder goes in the asphalt and you cross your fingers. Most of the time it works. Well, aramid fiber, what we're trying to do is get upstream and actually test the product that's going into the mixture, just to add another layer onto it. With that, Surface Tech has put forward also a quality control plan that they sample and test. I'm receiving samples monthly, where those would be they'll be held at my laboratory, like a split sample, if you want to think about it. And the manufacturer is going to be checking those products. They check them. They're always checking for length, wax content, all of those things, certificates of analysis that come with the product. So this is not something that's just sort of halfway thought about. There's a lot of details that goes into this engineered product that's being put forth to you today. And that's why when you look nationwide and you see these products, and they only showed you one, I could show you another one in Plainfield, Indiana, that's been tracked for 5 or 6 years. I could show you the airport projects I've worked on, Love's truck stops, the high level parking stuff that I've done up in the Northeast, on and on and on, that they could continue to show you. But overall, the product works. And now what Surface Tech is challenging the industry to do is let's standardize what we're doing so we have a consistent product going forward. Surface Tech is absolutely not afraid of it, and they welcome that challenge and want to make sure that for now and years to come, that it's a consistent product that's being offered.
Great. Thanks, Phil.
Well, and Mike, I guess one other little highlight I should mention, I just got back from the NCAT test track. And I got to actually go out on it and walk it, all the sections with the rubber, the aramid fiber, the plastic, all of them are looking good, and it's really, really early in the process. But a really cool note is that NCAT had a really high stress area where they enter the track on the entrance ramp, where they're having problems where it would fall apart in weeks or months. They wanted aramid fiber put down there just to see, really hit it with the torture test. And now, a year and a half into it, it is absolutely beautiful and still working. So more to come. And as you know, it's at the Minroads test track, the NCAT test track, going through ASTM, a lot of different things happening. And I just got a note that University of Rowan is putting together some stuff where they're looking at it for Department of Defense.
Great. Yeah, I think it'd be a perfect product for the Department of Defense, actually.
Yeah, it would bulletproof the roadways.
Yeah. Yeah, as well as being super easy to take around the world, which, unlike a lot of other additives, might be pretty challenging. Okay, I think we're headed down a rabbit hole. So Abby, we'll hand it right back to you. Unless anybody else has anything else. Wait, we've got some more chats. Let's see. How long will you be collecting data on the NCAT test track? As long as they'll keep it in place. They tend to study it. That is a NCAT call, though. We just continue to be updated as they do their research.
Yeah,
Is
and
the ASTM spec available, or is it still in draft form? The ASTM spec is in draft form, but we'll be finalizing that in person at that upcoming meeting next week that Phil mentioned. So as soon as we have it, we will put it out to the world, Karina. We will make sure that the ASTM spec is definitely available as soon as it is available. I'm sorry, was that you, Phil, talking about the NCAT?
Well, all I was going to say is that they're about a year and a half into it. It's a 3-year experiment. And I asked yesterday, I said, what happens when if nothing fails? They said, well, we just have to extend it another 2 or 3 years. So Yeah, and you can actually go onto the NCAT test track and look at how many cycles have been put onto it. So you can go and go to the website and actually look at some live data.
And Karina, you already were on the list, just to let you know, for sure. We had you on the list. So we will make sure that is circulated accordingly and that you guys are all aware of that specification for use, since it'll help everybody by all playing on the same level playing field. Okay, well, that takes us right to 2 o'clock. So I think that's all we've got. If anyone else has any last questions, great. Otherwise, Tony, Abby, thank you.
Yeah, thank you very much, guys. Very informative.
Thank you, sir.
Thank you, Tony, very much. Thank you, Abby.
Thanks, everyone. Have a great day.
Nice
All right,
to meet you all.
folks.
Bye now.
Have a great one.